And if we're done early, maybe I'll try to get that answer key up on the smartboard. We can even go over that today. Okay, so first, we're going to look for y values that are 0. Here we have one. Here we have one. And y values that are 1. Because when you square root 0 and you square root 1, those stay exactly the same. Any values that I could easily square root? Well, I can square root 4, so I'm going to make a big red dot where it's 4. And if I go straight down, the square root of 4 is going to be 2, so there'd be green dots there. Now, between 0 and 1, your y values, when you square root something between 0 and 1, it gets slightly bigger. In this case, it's going to be really hard not to go, like, can you see yourself being tempted to go back in time? Like, the best you can really do is like, oh, I wonder I went back in time. Like, almost the best that you can do is just like draw right on top of the line. Try to be slightly above. And then after that, it's going to go. And this section in the middle, your y values are negative. Can you square root negatives? No. So if we know the basic rules, that square rooting 0 and 1 stay the same. If you square root something between 0 and 1, it's slightly above. And square rooting something bigger than 1, well, that's usually ones you can do in mental math, like square root of 4 is 2, square root of 9 is 3. That always makes it less. So let's look at the next example. Do I have 0? Yes. Those will be the same. Do I have y values of 1? Yes. Those will be the same. Oh, I have hardly any room to be slightly above. I hope you can see that already. Any nice points? Well, here is 4. So the square root of 4 is 2. Go straight down to 2. And here is 9. Square root of 9 would be 3. Here I have to go slightly above and basically just draw almost right on top of it so that I don't go back in time. It's kind of a weird graph. So sometimes you're going to get graphs that look weird and you have to just be confident and say, as long as I follow the key ideas, square root of 0 is 0, square root of 1 is 1. When the y values are between 0 and 1, it's going to be slightly above. And when I square root something bigger than 1, it's always going to be smaller. This is what I end up with the graph. Now for each of these, they want domain and range. So the domain here is a little bit tricky. You could either write it like this. X is less than or equal to 1, or x is bigger than or equal to 5. That's how you would write it in set notation. In interval notation, you would say negative infinity to 1, square bracket because it's included. We use a big U for or, and 5 to infinity. And the range of this one, the y values are bigger than 0. Here, our domain, in set notation, you go from negative 3 to 3. Or in interval notation, you would write this as negative 3 to 3 in square brackets. And our range, in set notation, the y values go between 0 and 3. In interval notation, that would be from 0 to 3. And questions for practice here, circle number 8. You should look at the example on page 85 as well. It's a parabola, and the square root has no values between 0 and 1, just had a value of 1. So if you turn back to 85, to that square root of x squared plus 1. You'd only have one point that stays the same, 1. You have no points between 0 and 1. So everything's going to be below. Here, I'll see if I can find that one. Yeah, here it is. So if you started with x squared plus 1, the only place where it's 0 is 1. There's only one place where it's 1. And then I could say, well, I know the square root of 4 is 2, and I know the square root of 9 is 3. So I would have that also on this side, and then 9 there. And that's all you could draw. So math is sort of this way. We have these big ideas, and then you just have to apply those same ideas in a bunch of different situations. But sometimes those situations seem a little bit weird. Like this would be one where like, oh, there's no 0. How do I do that? Well, still follow the rules exactly the same way.